I'm Josh Batchgalupi. At San Francisco State, I'm going to challenge the status quo of the digital revolution and propose an entirely new paradigm, one that will show the discrete binary view to be a subset of a much larger integrated existence. Leon Theremin introduced his touchless instrument to a fascinated American audience in the 1920s. Here's a theremin I built. It continuously senses my proximity as I change my relationship to it. That makes it an analog device, not digital. Digital doesn't sense. Digital computes based on discrete input and pre-existing rules. Digital doesn't vary with temperature, light, time of day. New media today seems almost synonymous with digital technologies. At San Francisco State, I'll challenge this preconception with my new medium, which will be continuous waveforms and the analog circuits that help mold them. By design, ones and zeros don't interrelate, while analog signals do relate with other signals and the environment. They superimpose to strengthen and weaken one another in a complex sea of wave landscapes. At San Francisco State, I'll focus on molding these landscapes in an effort to better understand the patterns between us and within us. In design school, my boyhood interests in art and science came together as I learned how ideas interact with the physical world, how imagination molds matter and vice versa, back and forth. Professionally, I was exposed to the patterns of human behavior. Through process, these patterns became architectural topographies. Behavior molded the space, and then the space molded behavior. These hillside topographies bent the conceptual space. The topography of constructed space then carves the land. The designer's process mediates this give and take to realize the optimal solution. I submitted this design for the World Trade Center competition. It was my first attempt to illustrate this give and take between conceptual and physical patterns. This memory root remembers the 3D displays that were successful at gathering a crowd. The mechanism then integrates these successful memories by superimposing past patterns that best match the current crowd into real-time displays. As the audience reacts, the display adapts, give and take, back and forth. Greetings! But what kind of mechanism can realize this powerful process? What kind of machine can learn? The theremin is a good start. The fixed frequency of this oscillator interacts with the varying frequency of the other, determined by the position of my hand. The superposition of these out-of-phase electromagnetic fields sum here at this diode to form a more complex composite signal. It's this beat frequency of the composite waveform that creates the audible frequency we hear. But to harness this power and truly move beyond the digital paradigm, we need another ingredient, memory. Like clay retains its form after being molded by the hand, our circuit too must remember the waveforms that mold it. At the beach, waves pound the sand to mold the undersea topography. This sandscape, in turn, modifies the wave behavior above, give and take, back and forth. This simple process is the fundamental unit of my new medium. Add to this the ability for one beach pattern to superimpose upon another, to create a more complex pattern, like the theremin. Beachscape upon beachscape, in concert with waves upon waves. My new medium will mold these inputs just out of phase enough to reflect an increasingly novel, complex, and integrated vision back to the environment.